Good morning, good evening, good night, everyone. How are we doing? So, we're going to be looking at our blast from the past. If we look at problem 1, to show that problem, that this shape right here, the area of the triangle, the square, okay, is equal to the, 2r squared times 1 minus the cosine function in terms of theta. So, knowing this, we know that there's a thing called the cosine rule, right? Because there's cosine in here. Let's just do some association. Let's just try it with the cosine rule. We know the cosine rule is equal to a squared plus b squared minus 2ab cosine of theta, and that's equal to c squared. So, if we look at this whole area, we know that this area of a square is its one side length squared. So we can solve for a side length here of this triangle, because the cosine rule is for triangles. So we solve for this side length here, which is AB. We know that AB squared, okay? Let's write this down. Let's figure it out. AB squared, the whole thing, is going to be equal to, don't worry, A and B are not variables, they're rather points. We know that AB is equal to A squared, which you know that we can look at our triangle, and we know that those are in terms of R, so it can become R squared plus R squared minus 2. R times R is just going to become R squared cosine theta. Good job. So now we can do a little simplification here. So we know that we have 2r squared minus 2r squared cosine theta. Now we're really close here, aren't we? We see that we're pretty close to the answer that the document has given us. So let's just think about what we could do here. 2r squared minus 2r squared cosine theta. It looks like we can probably factor out a 2r squared, doesn't it? So let's try it. 2r squared is going to be equal to 2r squared minus cosine theta. Wow, we just proved that the area of the square is equal to 2r squared times 1 minus cosine theta. So, now that we have the first answer, let's move on to the second. It is when theta is equal to alpha, the square of ABCD is equal to the area of the sector. Write down the area of the sector when theta is equal to alpha. So, if we talk about this, we're looking at just the sector right here, which is going to be our components T and C together. So, we know that an area of a sector is going to be is 1/2 times the radius times theta, right? Is equal to the area of a sector. It's important to know that when we talk about theta or alpha, so the question asks us to put it in terms of alpha, so let's try it. Is equal to, we know that alpha must be in radians, or theta must be in radians, so that's going to make either our math a little easier or harder, depends on how you want to look at it. So, we know that that this is pretty much our entire problem. This is the answer to 1. I'm sorry, radius must be squared. So we know that's our answer. And we can move on and we can look at problem number 2, which is, or part 2 of problem B. We can solve for alpha. And the way we solve for is graphically, because we know that the area of the square is equal to the area of the sector. So we know that 1/2 r squared theta is equal to 2r squared times 1 minus cosine theta, or alpha. So best way to do that is graphically. We know that when we have a trigonometric function in our system of equations, it's best to solve them graphically if it's not a reference angle of 35, 45, 90, 0, if it's not one of those multiples. So best thing to do would be plug those into Desmos or into your computer, which is what you have on a test. And I would look at the graph. So you're given this exact graph, and to find the points, you would do second calc trace. Now, we know that our solution, okay, is gonna be, if we could look back to our document, it's between 0.5 and pi. So we know that this could be an answer. This is too large, so our only answer is 0.511 radians, okay? And look here, I have the same thing you'd plug into your calculator, second calc trace, and you would realize that these intercepts are invalid, and it's only the middle one that's valid. So we would continue going, and we would be able to write that alpha is equal to 0.511, which is what we saw on the graph. Okay, so now let's look at problem C, or letter C. This is a very difficult problem, so don't feel afraid or worried if you don't understand it necessarily, or it's a little difficult. It's made to be difficult, and you're still learning. So let's take a look at the problem. The question is looking for us to solve for all possible values of theta when the area of R is more than twice the area of the sector. So to find the value of R, there's a couple things we need to do. We need to find the area of C. So the area of C we know, okay, so let's not look at R for a second. Is going to become, the area of C is the area of our sector, okay, minus the area of the triangle. So we know that we can solve for C because we found those values earlier. So the expression for C, okay, is going to become 1/2 beta R squared. We know that this is the area for our sector minus 1/2 R squared sine theta. Now, if you're confused where this came from, this is from the area of a triangle in terms of variables with a trigonometric function. We know that 1/2 AB sine C. So we know that the area of this, okay, of this triangle part of component T is going to be equal to 1/2 times its radius squared, or its side lengths. So AB, which we know that is just radius squared, times the sine of theta or beta. So that's our terms of C. But now we're looking for terms of R. So we have to find the area of R. So we know that R, okay, the square actually is going to be equal to 2R squared times 1 minus cosine beta, okay, is equal to the AB squared, right? Or it's the area of the square. So we know that if we look at it if we think about it conceptually, we know that R is the area of the square minus C. So we know that this is equal to part C. We know that this is equal to the square, right? So we just have to subtract these and we get R. Wow, we're moving places. So let's write this out. We know that 2R squared times 1 minus cosine beta minus, in parentheses or brackets, just to make our lives easier and you can understand it, beta R squared minus 1/2 R squared sine beta. So now that we have this, we have to look at another part of the question. It's the area of R is more than twice the area of this sector. So we know that the area of the sector, so I'm just gonna write it here real quick, area of sector, okay, is equal to 1/2 theta or beta R squared. And this says more than twice. So this 1/2 is gonna cancel out. We're gonna multiply it by 2. more than twice. These cancel out. We get the area of the sector is beta r squared. So now let's look at the inequality of this, because we know that the question asks for all possible values of beta where r is more than twice the area of the sector. So we know that we're going to set this whole expression is going to be greater than beta r squared. So 2r squared, 1 minus cosine beta minus 1/2 beta r squared minus 1/2 r squared sine beta is greater than beta r squared. But now if we look at this whole thing, we know we can do a little simplification, because this r squared is here, r squared here, r squared here, r squared here. So let's divide the whole thing by r squared. It's going to be a big fraction. And then now we know that we can cancel out all these r squareds. This one goes away, this one goes away, this one goes away, this one goes away. So now we that 1 minus cosine beta minus 1/2 beta minus 1/2 sine beta is greater than beta. So again, if we look back at our other problem, we know we had a trigonometric function in our expression or in our equation or inequality. Only way to solve for it is graphically, unless it's a reference angle of 30, 45, 0, 90, or a multiple of any of those. So if we plug it into our calculator, do second calc trace like we did before, just plug in the expressions, okay, we get these values. And we know that the question asks when r is greater than, okay? So we know that r is this expression right here. When r is greater than our expression for our sector which is just in terms of beta, okay? This is like a plus minus graph. We know that's minus, plus, minus. So we know that our values are going to be between these two x values. Second calc trace on your calculator. Find out this is equal to 1.31. This is equal to 2.7 or 2.64. And there we can write the inequality that beta 1.31, we know that beta is going to be less or greater than 1.31, but less than 2.67. So there's the answer to C, and I wish you good luck on the second part of the problem.